Hello, my name is Thomas. I'm working on a video game, Ball Roller 2026. Today I'm working on the physics. I've so far successfully... I'll set up my problem a little bit before I talk about it. I have a glass sphere, and inside it is the player, small marble, and the glass sphere, I'm going to call it the ball. I'm going to call the glass sphere the ball. This is the ball, this is the marble. So the ball is tied to the accelerometer on the phone, meaning that the ball is undergoing acceleration. The marble is under the force of gravity, meaning it is also accelerating. So I want to find when the marble hits the ball, so I can do a bounce. So far, I have found, so in a physics engine, the world progresses at a time step, so this is seconds. I have mine set up to move forward at 1/60th of a second. In that time, the marble is going to move some amount, and I can find the position at the start of the frame and the position at the end of the frame. Similar with the ball, I can find the position of the ball at the start of the frame and the end of the frame, and I can see if, I'm under the assumption that the marble was in the ball at the start of the frame, and I can find if it's outside the ball at the end of the frame. If it is, I'm going to try to find the exact collision time, and then I'm going to try to find properties about the collision. So currently I have the ball falling, and then at some point I find that, so how this works is this radius might be 1 meter, and the marble radius is 1 centimeter. So if the position of the marble from the center is 0.99 meters, then there's contact and I need to handle the collision. Or it might be rolling, but that's for another day. Today I'm looking at how to detect the collision. So currently it doesn't work, but by the end of this video it will work, and I'm going to show about the method used and probably a bit about just techniques in getting to the bottom of your problems if you're getting into programming. Okay, so a bit more about this problem. There's a position vector for the marble, which is a function of time. So this vector, meaning it's an XYZ position, it's changing with time. It has an initial position. It's over time, it has a velocity, and 1/2 t squared. I'm going to call it, I guess, acceleration marble. And the ball being attached to the, through programming, being attached to the accelerometer on the phone is going to also be a second order polynomial. Acceleration of ball. And these variables, I guess I'll name them. IM is the initial position. Initial marble velocity. AM is just gravity, isn't it? And then IB is initial pole position. I'll write all these out because I'm debugging. So these are all going to be variables I'm printing and trying to get to the bottom of why my code doesn't work. So I'd like to make sure they're all named and accounted for. And they hopefully match the name of my code to some degree. This is ball acceleration. Okay, this is a good start. But what's next? I want to find when the distance between these two equations is the radius. So I probably could parameterize this with two more things. One is the marble radius and the ball radius. So we'll go radius of the marble is this, and then we got the radius of the ball what do we have to do next? We gotta say the radius of the marble. Well, we'll do this at the end because it's going to make all the algebra a lot harder. Instead, we'll just say, for now, the distance, actually it's scalar, isn't it? Oh, this is what we'll do. The radius squared as a function of t is the length of the marble position. So this you might call this the relative position. I did this bad. I didn't want that. P position of the ball. Okay. So mathematically, this is what we're talking about. We're saying there's a marble position and there's a ball position, and the length of that is significant because when it's the difference between these two values, then we've made a collision. So this will get into a lot of terms if we don't start doing some substitution. And I'd like it to match my code at the end, but that's not realistic because there's going to be more steps in the paper than I've reduced it in the code. But I'll just get started, and then I'll figure that out later. Let A equal... So what are some good things to grab out of this? So what's this? This is I'm looking at these two positions are going to be subtracted. So I'm looking at these two equations, and I'm going to collect, to start at least, I want a zeroth first and second order term, so I don't get a bunch of terms in this next step. I'll need to remember not to pinch next to the camera. So that's our first order term. So that's zeroth order term here, first order term here. Let C equal, there's a 1/2 there, isn't there? So it's nice here that the marble's under acceleration and the ball is under acceleration, but pretty early on in the method, they can just be subtracted. So it's nice that this doesn't become like a sixth order polynomial or something just because there's like, well, the sphere is going to be a second order polynomial, and the acceleration is a second order polynomial. So we're going to be ending up with a sixth or fourth order polynomial here. But it is nice that the positions and velocities and acceleration of the marble and the ball are just it's just a relative thing. So what we're left with is r squared is equal to the length of A plus okay. More good progress here. So we can see that taking the length of this vector is going to need a few terms. I'll say C, D. All right, these are going to be scalars now because they're dot products. D is equal to A dot A let E equal, oh boy, yeah, now we're just going through it. I'm putting a 2 here because when this, if this expands out, you get A dot B, but you also get B dot A. So it's like if I do all the permutations, like A B, AC, BA, BB, BC, CA, CB, CC. Look at all this undo I gotta do now. But anyways, but all that really mattered from that is that there's the version that goes AB, and then there's the version that goes BA. So there's 2 of them. What do I want to do here for space? Okay. F is going to be the squared term, which comes from 2 places, C dot C and also A. 2 of those. 2. Let's keep this neat. The power of undo. When I use paper, I also double tap my paper sometimes. Muscle memory. Yeah, probably. Oh, come on, iPad. No, I love my iPad. Let G equals on T3 now. Have I been remembering my vectors? Yep. Okay, E, G. Let H equal CC. And then, yeah, we're looking ready to express this thing. What's best here? start with the 0th order or the 4th order. I'm not sure. Okay. And so this is good enough for a couple things. If I wanted to know, I can plug in my t-value at the beginning of the frame and the end of the frame, and I can see that I've passed the threshold. And do you know what? That's sort of why I'm here, this is where I ended it when I implemented the code, but then when it doesn't work, you got to plug in some values and see if your code does what you think it's supposed to do. So actually, I'll derive a few more things, and then I'll start getting into taking the numbers from my debugger and plugging it into these equations here. What did I do here? I just quit. Just went home. What was I saying? I'll get into plugging the numbers from my debugging, or from my breakpoints. I print some values here. I print the marble position and the ball position, and I print the marble radius and the ball radius and the velocities and accelerations. And what I'll do is see why my code's not working. But I can what another piece I'll need for this is I can't just set the left-hand side of this equation to a value and then solve for t. You can, but chat tells me that it's not a great numerical option. So what I do instead is, first off, maybe it's worth looking at what does this 4th order polynomial even really represent. We're describing, so there's 4 solutions to t. That's what I really mean. What does it represent? There's a marble under acceleration of gravity and a sphere position, or a sphere described as also a 2nd order equation. So therefore, there are 4 intersections. And that's what we're doing here. So there's even internally, given the equation of the sphere and given the acceleration parabola, there is going to be four intersections, and it's about finding the right one. But algebraically, it is, I suppose, not great to try to find the roots. So 2nd order polynomials do have the quadratic equation. So we're going to try to work with that. So why did I erase that? That was kind of a nice diagram. That would have been, it was kind of messy. Now maybe it is worth getting rid of. If I'd done a nicer job, I'd keep it. But a 4th order equation has crosses 4 times. And at any point, it can be approximated as a parabola, as just a basic old 2nd order differential equation with only 2 crossings. And that's what the method is to, given this 4th order curve, at every point, I have the equation, so at each point, I can use that equation for each value of t. I can find the position, the slope, and also the acceleration at that point, which locally is a pretty good way to approach this. It'll take iteration, because once I have I'm trying to find the root, and I'll almost find the root, but it won't be exact. But then I'll have a value of t that's a pretty good value of t, and I'll use that to reevaluate the position, velocity, and acceleration at that point, and then that will get me to the final solution pretty quick. But numerically, I'll only be working with the quadratic equation, and I'll be approaching the final solution for the fourth order polynomial. So, I need a few more variables because I care about the derivatives now. H, I need some I here will be good. H, I, J, K. Oh, I left that underline there. That's annoying. So what do I call this? Let's not forget it's r squared. That's a big mistake. Can't forget this is r squared. If you forget that's r squared, you're toast. Yeah, but I need to define some of these. Okay, let I equal, what's going on here? 2 times f I. I'm just gonna do these all in line. J is 3. H is 4 times. No. And then down here we have oh, I see, I misaligned these, but that will be fine. L is equal to 2 times J. M is equal to 3 times K. Okay. And then, but that still doesn't quite say what T should be. T, say T prime, is equal to the quadratic equation, negative, B plus or minus, all right, we're going to the back of my brain where I remember all the really old stuff. What did I do? Oh, it is, okay. Double prime, the acceleration. So I maybe skipped a step where I showed that T is equal to somehow a function. I skipped the step where I showed the sort of quadratic form. I'm just going straight to the quadratic solution where these are the three coefficients of the polynomial. So this here talks about, again, this quadratic equation. If we pick a point, we can find the position, slope, and also acceleration, which is a quadratic form. And if the fourth order polynomial is going through the curve, we can find the second order polynomial, find where that goes through the curve, and then finally we update our t to be our t prime. The t can go back into the original fourth order equation, and you can see if it in fact equals these values, the marble radius and the marble ball. That's the value we're going for. So yeah, that's the method, and it's not quite working. I'm somehow, well, chat says that my method finds the 0, but then it continues going, and I think that's a fair enough explanation. That is probably what the problem is, but I'd like to understand the method better myself, and also that's sort of the point of the video, I suppose, is to show the setup for some of these physics that you might run in an engine, and then show how you sort of step through it and confirm that it's working correctly. Right now it's not working correctly, but I'm going to start plugging in some values here. See what's going on. Okay, what do I think is worth noting here? I'm printing stuff every frame, so I gotta find where the loop starts. Okay. That can't be right. What's going on? No, that does make sense. Okay. So, a bit about my setup. I have, again, that's, okay, ball and 0, 1, 0. So this is saying x is in this direction. And you know what? Why don't I just acknowledge that the coordinate system is down here? X, Y, and Z. The marble is down here, and we are no longer doing algebra, we are doing numbers, real numbers. Okay. What did I call them? I called them initial marble is equal to, is going to be annoying that I really shouldn't round off any numbers, because there's a decent chance that the problems here will lie in the floating point evilness. That's an industry standard term. What else was worth noting here. So I'd said that there's a ball initial position, I said that there's a ball. Yeah, I did say there's a ball initial position. There's a ball velocity, and there's a ball acceleration. I know what the ball velocity is because I subtract the current ball position and the previous ball position. So I know I had in the previous page defined this value, which is, how do you notate vectors? I forget. I had, J had, Z had. Oh, right. It's been so long. 0I plus 1J plus 0. Okay. And how do I denote previous? Prime, I guess, is sort of it'll serve for now. Sort of a boring result. I'm not debugging on my phone. I'm debugging on my desktop, which means the ball is not under acceleration. Its position is remain the same. Let's call these vectors. Let's be proper about this. That's incomplete. That has to be incomplete. Yeah, I was shorthand about this. Actually, it's okay to be shorthand about this. I think it's sufficient just to say J there, and I'll do that going forward. Leave out 0 terms. The velocity of the ball is therefore 0. And it should be noted that this needs to, because it's discrete, what's the time here? Velocity is position over time. That's going to be the frame rate from earlier, 60, or the physics frame rate. Not the same as the frame rate of the game. I've made that mistake. So the physics frame rate is 60. Immediately it's a problem. The frame rate of the engine being tied to the frame rate of the game is, like, as soon as you start debugging, your frame rate is like however long it's taking you to debug, hundreds of seconds. So that immediately doesn't work, but it's going to keep not working for other reasons. You can't have your game start slowing down to 15 frames per second and then have things start clipping, and because if there's a bigger problem there, because the longer you take to render, the more physics you're going to have to do in that time step. So you're just going to there's going to be a catastrophic failure. So I guess it's easiest just to do it at 60 frames per second and make sure that doesn't happen. So it's a similar story with the ball acceleration, where I have each frame I'm doing the previous, taking the current ball velocity and assigning it to the previous ball velocity, where this one would happen first. I'm going to leave a note. This one happens first, and then this one happens. And then that sets up the ball acceleration, which is going to be, of course, the velocity of the ball minus the previous velocity of the ball, and that being multiplied by 60. The inverse of, so I'm multiplying by 60. That might seem a bit strange. Change of position over time. Where's the over? This 60 here is per seconds. I can't start putting in units. It'll become such a mess. But the 60 there is the inverse of the okay. What's next? So we did the ball's velocity, the ball acceleration, remaining time. So remaining time is I'll call it RT. My equal signs are so... Come on, guys. Get in line. 16 milliseconds, 1/60th of a second. So this means the frame starts, the ball has not, or maybe it has, no. The frame starts. And then for 16 milliseconds, 17 milliseconds, the ball undergoes acceleration. Sorry, the marble undergoes acceleration, the ball undergoes acceleration, and they may hit, which means that I can't do all the physics in one go. I have to, if it does hit, figure out what time it hits at, a number less than this number. I'll call it collision time is less than, and then the remaining time, there's a better name for this, T subscript R. Oh yeah. And then I need to subtract off the collision time and keep going. There's this situation where it could hit the sphere twice, huh? It could be riding around the inside, hitting the sphere multiple times. Could happen, probably will happen. So we'll be, and as this gets more elaborate, if there are more spheres, it might hit multiple spheres. It might also, once there's a level in the game, the ball might hit make multiple hits before the physics frame is over. That's enough of an introduction to remaining time. So this is at this point 17 milliseconds, 17 milliseconds. I said I was going to keep all the digits. I should probably do that. Physics frame time, I'm not even going to print that one. This shouldn't be an issue, but it's worth noting. I'm just so I can watch it a bit closer. My gravity is not 9.81. My gravity is acceleration of the marble is negative 0.04 meters per second squared. Did I already write down marble position? Wait. $29307? Yeah. So by the time we reach the bottom of the ball is moving downward at 1.22329 meters per second. And then the collision occurs. And the new velocity is wrong. I'm not even going to write it down. Wait, maybe it's not wrong. It is wrong. It's definitely wrong. What does this mean? new velocity. Well, I should write it down because it might be. Let's see what it represents first. I'm saying new velocity is negative 0.0 no 27999 in the I direction. That must be wrong. Cannot be right. But how was it made? It was the marble velocity plus the physics frame time times physics gravity. So when these things go wrong, the best thing to do is to look at the inputs to the equation and to print those and to see if those are what I expected them to be. Because if the equation seems right, but the output is wrong, then it's probably that the inputs are wrong. That's your wisdom. Thank you for watching. That's what you gotta know. So I'll write it out. I'll make these briefer. This isn't my code, so I don't need it to be readable. I need it to be brief. New velocity is negative 0.02799 which is wrong. Let's look at the equation. And V is equal to marble velocity I maybe should have defined this after. P is 1/60, which is physics time. Maybe more consistent with this document. Might be to say that the marble velocity is equal to the previous marble's velocity plus the physics time times gravity. Okay. So next thing I'll do is I will recompile my code, but I'll print those three variables right before the calculation and then right after the calculation. No, I'll print the three variables going into the calculation, and then I'll print the result value coming out of the calculation. There's always that chance that the variable was inadvertently modified after all that hard work, all that math, and then you just overwrite the variable later. That one sucks. They all suck. It's all just, it's so fun. It's all so fun. physics time. Physics frame time. And physics gravity. Alright, physics gravity is a vector, so I'll actually need to print a few of those. Okay, I have my print statement in here for going into the equation. I'll print my velocity coming out of the equation. And then, what's next? Recompile the code. Run the code. Hope I don't have 1,000 breakpoints scattered around. Takes a few seconds to, at an acceleration of 0.04 meters per second, it takes a few seconds to get to the bottom. It's getting there. It's pretty close now. Okay. So a bit more information, hopefully. Let's see. Where it is. V. Oh, I messed up my print statements. What a downer. Oh, well, actually, I can get a fair bit of information. I forgot that marble velocity is also a vector. So I have marble velocity, physics frame time, physics gravity. I needed to set up the string format to support 7 values. But nonetheless, I do get to see my marble velocity on this first pass. And I can see it's not what I expect it to be. I'll need to get into this. So, what do I see? Actually, it's not worth the risk. This might not be reliable information. I should fix this up first. One, 2, 3, 4, 5, 6, 7. Okay, the ball is halfway down. I could have made a briefer setup, but it all takes time. So what do I see now? Actually, yeah, it is good I fix that because it's different now. My new velocity may just be a misdiagnosis. I didn't print XYZ components. I only just put the new velocity in directly. I don't know how the compiler interprets that. What happens if you put a GLM vec3 where it expects a floating point value? What am I seeing? I'm seeing and I'll write them down once I start compiling again. Actually, I should write them down first. I see VM eyes are getting too weak for this. 223329. How do I zoom? There. I'm reluctant to write down these numbers because they're just numbers I've already written out before, but then I'm remembering that that's the whole point, just to confirm that they are what they are supposed to be. In a second here, I'll see that there's a simpler physics to confirm that this is the correct value, because I know I'm just a ball falling 1.9 meters minus, or 1.8 meters. So that should be an analytical solution, and I can confirm that. Okay. That's all. That's everything I expected. And now I will recompile, print the new velocity again. I just done a blunder in the formatting, so I feel probably it's going to come out to be the value I expect. What value do I expect? I think it's going to bounce off, and it's going to be the negative of this value. And yeah, why not? Maybe I'll start talking about the bounce a little bit. Well, no, I'm not there yet. First, I need to figure out why it doesn't resolve to the time, the correct time. And the new velocity here is only supposed to be, how do I say it? Yeah, what is this velocity supposed to be? This velocity is... This velocity is the velocity at the end of the time step. So I've used this velocity to find that the position is outside the sphere. And then I'm going to use, not much of that, I'm just going to use that to decide if I'm going to need to step into the finding the exact time. And finding the exact time is going to involve that numerical method I showed earlier, in which there's a problem. And now I do see. So right, this exercise, as a math lesson, is essentially useless because all I've done is shown that the equation is correct. But I just maybe I just want to show, at the heart of this, what is the wisdom? When your thing isn't doing what you want, check the inputs. If the inputs aren't correct, look there. If your inputs are correct, give up. No, it's somewhere else. The problem is somewhere else. Okay, I can believe that. This number is more negative than this number. So it does seem to be accelerating downward. What else do we see? New position. What do I call the new position? I'm all over the place. I've already used prime to denote the previous. So I guess I'll just say I am. So this is the position that is supposedly outside the ball. Okay. So the ball is 8 millimeters off the ground, and the ball has a radius of 1 centimeter, which means that it is collided, it is intersected at the end of the frame. But we're not going to let that happen. We're going to find the time where this value is that, where we collide exactly. So I have this marble hit ball function into which I will step, and we will look at this a bit closer, see what it does. It's going to implement the method I showed on the last page, but it's not quite working. So the first 3 variables I print are the position, velocity, and contact radius. Those must be the marble. Yeah, the marble. So I've printed the position correctly. That's the value I expect it to be. That's the value it is. And that's what we're doing here. We're confirming our values. And I also wanted the contact radius, which is, I'll just call it RC. And this is also the radius of the ball minus the radius of the marble. Okay, keep going here. Algebraically, I'm going to need, the collision is going to be about finding the zeros, and the zeros of the function involve subtracting the r squared from both sides of the equation, because we had derived the r squared t term and the derivative of it and the second derivative of it. So we're working with r squareds here. Relative position. We had derived on the previous page that one of the early, actually I have it here, why am I talking in hypotheticals? There's a this term here, and this term here. We saw that it's just relative, like whatever the ball position, the ball velocity, the ball acceleration, they can be subtracted to produce those variables. And I think I'll just, if they're already named, why not just go ahead and use those names. In my code I had them called relative position, relative velocity, relative acceleration. See, is this bad? This feels like, no, okay, maybe this isn't bad. I just got myself mixed up. Wait. Oh, A. Okay, I need to start with, I know. I just got confused because I'm used to A being acceleration. Oh, right. I'm just checking values. I'm not doing algebra right now. Yeah, that makes sense. This is talking about a ball relative, right? So the center of the ball, the marble is down here. And is that what I expect it to be? That's why I'm here. What do I expect it to be? It's the dot product. Not yet. I haven't done that yet. I haven't found it yet. No, this is just this feels like there's a problem here. This isn't supposed to be A. A is the dot product of the relative position with the relative position. So I actually am doing another variable here. Is that right? What did A was... No, I'm thinking of D. D is the dot product. A really just is the relative position. Okay. So maybe this is weird. I'll just write down the number, and then I'll try to rationalize about it in a minute. So this isn't the value I expected. I expect it to be 991. I can't even do subtraction anymore. But somewhere around there. Definitely off by a couple. Because it's should be 1. It's off by 3 centimeters. Oh, right, this is the start of the frame, so that might be correct. This is a IM. So was that jotted down anywhere on this page? Yeah. Okay. I'm becoming more convinced by this value. We start at 0.976. And what did this value mean? This value meant is that the marble position or the marble distance from the center? No, it has to be the... Yeah, the marble radius is not yet considered. This is just talking about the 1 meter radius of the ball. The y position of the ball at the start of the frame relative to the center. And that is consistent with that IM number, which is the height of the ball off the ground. 2.9. Perfect. And the velocity, relative velocity, and finally, let's remember this relative acceleration is not the most descriptive name, but it does sort of keep everything a bit more concise. It's actually 1/2 of, that cannot be an addition there. I remember I threw this in later as a touch-up, so therefore I messed it up. This might be a problem. What does that mean? 0.5. I've written here relative acceleration is equal to 0.5 times smooth gravity minus ball acceleration. What have I done here? I wasn't supposed to use smooth gravity. Smooth gravity is the gravity I get after applying smoothing to my cell phone sensors. The value I was supposed to use was something multiplied by the gravity of my world, some constant value. Where is it? Okay, well, this is reassuring. It's sort of, I'd like to better imagine how it results in what I'm seeing. This is the first bug. Physics gravity. Is this somewhere public, or no? It's a private member of my class, and the method I'm working in is also a member of the class, which means I'm free to go ahead and use physics gravity. I've lost my spot in the code, though. Here we are. Smooth gravity being replaced with physics gravity. I have half the mind to print these variable values, but I'm not desperate enough yet. For now, I'll just see if they're fixed now. Okay. The ball is falling once again. It's in free fall, a very small free fall. So what have I seen so far? We've seen the initial position, the initial velocity looked correct. The initial acceleration was wrong. But we'll see now. Sort of the relative acceleration is good, is now a better value. A value I like to see. Negative 0.02J. So that's half of, let's go back to the form. I'm looking at this equation here. I know the ball. I know that this term was 0. This term was 0.04. Negative 0.04. And keep on going then. So now I have, I'll have to transpose them. They are these variables A, B, C, D, E, F, G, H, I, J. And those are associated with what looks like D, E, F, G, H, I, J, K, L, M. That'll be fine. I can just translate them. Just starts at D instead of A. Oh, right then. But you know what? Instead of just writing them out, it's worth... No, I will write them out. And then we can go back to the equations and see if they seem correct. E, F, G, H, I. Actually, just so this doesn't get too repetitive, I'm going to do them one at a time. Okay. D here being A dot A. So what did we expect this one to be? That seems really wrong. That seems way off. D, relative acceleration. Oh no. Maybe I put this all together like... maybe I flipped all the terms of the polynomial. Or at least in my code, I think I did. So I think I had the same confusion I had when making notes during this. I think I made the same mistake in my code. I'm all over the place. Misinterpreting A as acceleration. So here, why is this? Okay, A is relative position. D is relative position dot relative position, and then ultimately that becomes a 0th order term. Now what have I done? A is relative acceleration dot relative acceleration. Okay, we're on to something here. A needs to be relative position, and by A I mean I'm again transposing here. A, maybe I'll just I think I'll make my code match these notes, and then I won't keep making mistakes. How did I end up with, okay, no, that's right. And surely I'll have to update other parts of my code, but as we're stepping through this, I'll make the updates. Confirming the values, JK. Okay, I is equal to 2 times F. J is equal to 3 times G. K is equal to 4 times H. L is equal to 2 times J. M is 3 times K. Okay. So D, relative position, actually, it wouldn't even hurt. I'm going to call my relative position A. No, I don't like my code that way. Okay. E, position, relative position dot relative velocity. F, where's F? Relative acceleration. What? Let's see. Two times AC. That one actually doesn't have to change. I confused them, but now they're swapped, so they remain. Actually, I'll switch their position in the dot product just to say I did. C dot C. No wonder my code didn't work. There's just so many bugs. C dot C is acceleration. Dot acceleration. That cannot be right. That was supposed to be velocity. This is velocity. Velocity. Yeah. Sometimes you just need to do it all twice, and then you're still not done, and then a few more times, and then it works. G is velocity and acceleration. Wow, so many problems in my code. Well, once you flip the polynomials, if you categorize flipping the order of the polynomials as one mistake, then all these mistakes are one mistake. H is... Oh, I see. At some point, you have to acknowledge that you're trying to... You're not trying to make this 0. You're trying to make this... Right, this. This is not needle length. This is a scalar. These are scalars. So then that needs to come off of this term. No, it doesn't. This is back when I had things bad and backwards. It's supposed to come off this term, I think. Something like that. See, chat, you ask chat, and it doesn't tell you that you flipped your polynomials. It just lets you live in your ignorance bliss. It just says, good work. You are so talented. Where are my notes? Okay. D plus ET F G H E j k I L M All right, that's time for me to eat some food, I think. Okay. Back to it. Where was I? We were debugging. Oh yeah. Okay. Oh, I should have recompiled before starting the video. Okay, I'll talk to myself to get re up to speed. A was initial relative position, relative velocity, relative acceleration. D was incorrect, and my marble is falling. It's about halfway down now, so before long I'll be back into printing variables. Okay, stepping through some code. All right, some new D values, E values, etc. D 375856. Okay. Is this value correct? What was this value supposed to mean? D was relative position dot relative position minus contact radius. So this value should always be negative. And if it goes positive, the ball's outside. And this is the initial position. So this is the initial distance from this value is negative. Negative is relative position dot relative position minus contact radius. So contact radius is the negative part. Should be big, but this is should be negative, and it's also related to r squared rather than r. I'm trying to figure out what I expect this value to be. So that should probably be the square maybe. And I'll step through a bit more, see if this makes a bit more sense. But what are the other values? DE is... Wait, what is... D... A dot A minus RB minus RM squared. So I think the first thing I got to do is RB minus RM squared. What's that? 0.98. I feel like I did have that written down here. Okay, so I won't write this down again. And what's A dot A? .449. So the difference, this minus 9801, and that's looking believable. I can get into this value, 0.9422449 minus. I think I might even go get my calculator. I'm doing a lot of I did not write a lot of digits for that RC squared. That's too bad. But it does look like a very close value. It does look just right. I hope that was a good racket. So that's one value down. That's one value that looks right, and we have a bunch more to go. So E is, but it'll be faster now. Now I'm back up to speed. I ate a banana. I ate a yogurt. It takes some time to get back to programming after you have a yogurt and a banana. 2, 3, 7, 4. And what's that equal to? That is E. I didn't even step through. I didn't even watch my code. Who knows? My code could just work right now. But that's a dangerous thought. You'll get discouraged if you think your code works after you find one bug. 2 A dot B. I just stood up to get my calculator. Here it is. Okay, A is negative 0.97069 times negative 0.037856. And I'll multiply that by 2. And I'll get 0.7349. Now, why'd that happen? Relative position, relative velocity. Relative. One of those numbers was far too small that I put in my calculator, I think. Yeah. Way off. How did that even happen? I'm concerned that it's still not going to be the right value, but I might be wrong. Ah, yes, bullseye. I think. Oh. Okay. 2 down. F. 1 point. And what was F equal to? F was on the other page. B dot B plus 2AC. Alright, here we go. 1.223329 times 1.223329 plus 2 times 0.9769 0.02. Where does that leave us? Pretty good. It's a pretty good thing to see. Okay. G 0.048933. And what was G? G was 2B dot C. B dot C. Plugging those into my calculator. 2 times negative 1.223329 times negative 0.02 gives 0.04893316. H. Oh man, before you know it, we're almost there. H is equal to, oh, I should just get the literal first. 0.942245. And what do we say H is? H is C dot C. Oh, we are like not really halfway done because I left out stuff. I could do this one mentally, but I love the comfort of putting it into the calculator. Uh-oh. What'd I miss here? There's like I forgot a term or something on this one. H is C dot C. Oh, I did mess it up. See, this is why you never assume that you found all your... You don't get too excited. You don't, like, find a bug and then, like, think it's gonna work. Okay, I'd put my relative position there twice. Relative acceleration dot relative acceleration did not show up. Well, that's drop. All the ball drops. New Year's Eve, New Year's Day or night drop. I forgot some of these variables. I, J, K, L, M. Just when you thought you were done. This is also how a lot of development goes. Am I printing them? D, E, F, G, H, I, J, K, L. What was the problem here? Oh, right, my H value in my code is good now. Correct number zeros, 1, 2, 3. What? What? Okay. I. What do I get from my code? That's pretty big. .07022. And that was 2F. Is that it? 2F? Two times 1.5353615 bullseye. Not bullseye. What do I think of that? I think good because it was a typo on my behalf. I blundered. Okay. J. What do we see here? 0.146799. And how is that represented? 3G. Man, those were the days. 3G, those were the days. This one is hopefully straightforward. Hopefully these late ones are not too much trouble on account of them just being multiplications. I mean, it's all just multiplications, isn't it? Except for the additions and other stuff as well. .016 4H. Did I write down that H value wrong? No, that looks right. L is 0.293599. L is equal to 2J. 2K or 3K? Three times 0.0016 is 0.0048. Okay, alas, we've done it. We've seen that the coefficients seem correct, and we can move forward. The next thing is this part of the equation here, or more like these three values. So I'm going to print those from my code, and then see how we like them. T is 0. Do you know? I think I'll work it out on paper first, just to switch it around, and then. Well, it should be really dead simple, shouldn't it? Because T is 0. So it's just D. Well, and then speed is just... Let's just get started. Let's just write it down. Oh, no. Come back. T is equal to... just D. Well, R0 is just D. And this is still R squared, let's not forget. And it's not even well, it is R squared, but it's more like R squared minus ball radius minus marble radius squared. Oh well, but no, I don't need to worry about it, I don't think. D... What else was there? E and I. Oh, do you know what? I still need some practice at this. I should have set up my print statements, compiled my code, and then started setting up the problem. Okay, distance. I'm making my printf distance, speed, acceleration, FFF, new line. What else will I want? I should look into the future a little bit for myself. No, there's like a healthy amount of print statements in here already. About the discriminant, we're about to come up to a square root, so there's gonna be some checking of negatives, and there's gonna be some division, so there's gonna be some checking of zeros. And I don't know exactly what to do yet if the quadratic equation doesn't intersect 0, which surely could happen. I mean, it's a numerical method. Of course, these things can happen. I think probably just approximate it along a line. I don't know if that's going to be really broken. I may get away with it not having a perfect, robust method because it starts with the assumption that the marble is inside the ball. We'll see. So there's like the ball under gravity is going to leave, the marble under gravity is going to leave the ball eventually. Maybe not though. Maybe if the ball is under acceleration downward, the same as the marble, locally will look like it's never going to intersect. I'm not sure if that will break anything. I'm worrying too much about something that isn't a problem yet, but I think it will be a problem. We'll see. Getting coefficients were right. Okay, I got some values here. In the code, I call it distance, speed, acceleration. That's r0, r prime 0, r double prime 0. And I have seen that they are negative 0.037856 and 2.3745. Nope. 4953. I'm not even glancing down to see if these are all correct. It would be so quick to just look down and see. Okay. D, E, I. All right, that's pretty good. And then what I'm saying, if you call this A, B, and C, you can say T is equal to negative B plus or minus square root of B squared minus 4 AC all over 2A. And so this term is interesting. This one, that there's the discriminant. Oh, what a waste of time. In the 2 lines later, I already had a print statement to print the speed and distance and acceleration. And the discriminant, all 4 of them. Oh my god. All right, discriminant is I'm not gonna write discriminant. I'm gonna write just as many symbols, but that. Okay. Get up the calculator. What do I think this should be? B squared 2.374953 squared minus 4 times 0. Negative? Is that a little negative symbol there? That is. How many negatives do we have? We have 2. Plus 4 times 0.037856 times 070722. What do we get? 6.10538. Good. Good. And then what? I say last t is equal to t sure, why not? And then a couple things. This might be 0. Yeah, that's probably more interesting to look at is what if it wasn't? Actually, maybe I'll get back to that later, because right now I just want to see the ball bounce. So yeah, it's not a case where what if A is, I think I actually say what if the absolute value of A is less than like a really small value, because that's just going to be crazy. If it's really barely accelerating, probably just call the collision time infinity and deal with it later. It's probably not going to collide. It'll probably be fine. Or just treat it as a line. I think that's what I do, is if the acceleration is 0, because it still has velocity, so it still might hit the wall. But if the acceleration and the velocity are 0, then just call the collision time infinity, because the whole point is just to progress 17 milliseconds. So that's if acceleration is 0 and the velocity is 0, just don't collide with anything for 17 milliseconds. So now what? Solving t. I guess I'll just step through. I already have some more print statements here, so I'm not going to make the mistake again. So I find some t values here. That's interesting. It's not that interesting. I mean, that's what I was doing. I get the positive and the negative root. Negative 0.78. So what is the meaning of this? Why would this have a positive and a negative root? Right, because I'm in a situation where the ball, and I hope the positive root is much smaller. It is, good. So in just a very short amount of time in the future, I'm going to intersect this downward edge, this downward face. But I guess the meaning of this is that back in time, I was going to hit the upper edge, I guess. Or actually, it might also just mean where it's a local parabola, it could just mean something more like that. So either way, yeah, it's good to see that the T2 is much in magnitude. It's much smaller because we're about to make the positive collision. Is that already a convincing number? That's already 15 milliseconds. This is looking good. Because the frame time is 17 milliseconds, so to have a collision that's less than that is a good start. And then my method is, what it's doing is it's keeping track of the last t and the previous t. So I have I'm getting ahead of myself. I should check these values. So I already have my discriminant. I did this a bit wrong. This square root wasn't supposed to be here. I'm really dragging my feet on this. I need to just plug these numbers into the calculator. Negative 2.373. Which one first? The smaller one, I guess. Minus square root. I'm going to set this form up first. How do I insert? Here. No, not like that. Okay. Minus square root divided by 2 divided by 3.07072. And inside the square root is b squared. What's b? 2.37453 squared plus 4 times 3.070722 times 0.037856. Error. Great. Oh, I forgot to put the... How did I forget that? Did I just run out of room in my input? No, I got it. Great. Awesome. Hopefully I can just press up and repeat a lot of that. What? Wrong layer, wrong color. I should zoom in so I don't take up too much room. and the other result. What do I put this? I need to change this to a plus. And what do I get? Yes. 5, 6, 2, 4. Good. Good. Continue on then, iteration. It's interesting. I thought my method would plug the t value back into the quadratic and see if it's reached the final solution, but it seems to instead be doing keep going until the result stops changing. I wasn't paying attention while I let the thing keep on going. I don't know how to interpret these values the next time through. I guess I need to do what the code does, and I take t is now equal to 0.015624, and I need to go back and get new a, b, and c values and see if this thing is converging. Yeah. It wouldn't hurt for me to put this fourth order polynomial into Desmond or something and see how it looks. But maybe I'll... Did it print the... Right, the AB... Those values don't change. Okay, I can at least see that my distance has gotten quite a bit smaller. That's reassuring. I actually maybe am losing patience to keep stepping through this. If the distance got so much smaller, I might be losing interest in doing the numerical method here. Let's see. Oh no. It didn't get better, it got worse. Which means I'm not done here. Let's see, distance. Let's see what it did. I had in the... Why did I erase that? That was pretty valid. But the t was what it was. Yeah, that's good. Okay. In the next iteration, this is looking good, and it's going to go sour. But it's good right now, where the distance has dropped. Where were we? Our distance was 4 centimeters? And that's something to do with squared or something like that. So it's not exactly, but we want that number to go to 0. So we're getting there. Our distance is a couple zeros. What's our speed? What was our speed last time? Our speed last time was positive. Our speed this time is, unsurprisingly, still positive. That should make sense. We're not stepping forward and backwards that far. I'm just copying the wrong number. I'm copying the number from on the page. 375. Yes, it is a tad different. We moved a couple milliseconds. the acceleration. Is that surprising for the acceleration to change? Why would it? There's something about that seems odd. Because I guess it is a sphere, but everything's perfectly aligned. So I'm surprised to see the acceleration not be the same. Why is this the case? Why can't the acceleration be the same? Because acceleration is a function of time. Why is acceleration a function of time? Because they were derived from fourth order polynomial. What is L and M? L and M is J and K, which is G and H. Because both the ball and the marble are accelerating? No. Because we're accelerating, taking the square of it. I suppose it could just be explained that we might not be axis aligned, but that doesn't explain why my values are changing. It's because L and M are non-zero. What's the meaning? Who knows? I'm spinning my tires here. I should be more concerned with something else. The discriminant is speed times speed minus 4ac, and distance is a lot smaller now. Maybe I've set up this wrong. Maybe it's supposed to be like that. Maybe, just maybe. Oh, how would that change things? How could that make any sense? That would be like saying the position of, do you know what? It's time to ask chat. It's time to ask chat. See if it has anything helpful to say. So what I'll do, I'll take my function, and I'll go to chat, start a new dialogue with chat. I'll say, here's my function, and then I'll say, here's my print statements, my output of my print statements. I'll say, it seems to converge, but then diverges. Please advise. take a sip of the coffee. It tells me what you implemented is essentially Newton iteration on the squared distance polynomial, but the update step you're using is not the Newton step. Because of that, the method can oscillate or diverge after appearing to converge, which is exactly what your log shows. Let's break the issue. The polynomial you're solving, your distance equation is that, which represents that, correct? The derivatives are that. Your code computes speed, acceleration, which is also correct. The problem is with the update step. You update t using negative speed, all that stuff. This is not Newton's method. You are effectively solving the quadratic Taylor approximation, but your coefficients assume... maybe forgot the 1/2 AC, the 1/2 factor, the correct quadratic step. So their chat, and we'll see about this. Chat is saying, what is it? There's a 1/2 missing. This is either a 2 or 1/2. It says my discriminant should be 2 AC. I'll try it. I'll try anything. That's not true. What do you think? Comment, like, and subscribe if you think chat is going to fix this for me in one go. Now, how do yeah, it's probably, breakpoints are probably fine. Still just a little bit regretting having such a slow drop on the marble. I could fix it at any time, but I don't. This might work. It might work. It could work. It's convincing. I sort of was thinking a little bit about the 1/2, but I sort of just thought algebraically, if it was supposed to be there, it'd be there. Okay, let's see. How's it start? The t values are looking very similar. Okay. Show me a smaller distance. Sort of funny that the distance didn't converge quite as quickly, but that's just a coincidence. That was like, I just got lucky to converge that quick. The real moment of truth is now when I see, has the distance got smaller a second time? It went 37 millimeters down to 19 millimeters to 28 millimeters. No, too bad. I was hopeful it would just give me the goodness right off the bat. Okay, well, I'm gonna show it what I did. I'm gonna go shame chat. I'm gonna say, look at what you made me do. Now, what should I send it? I think I'll send it my new outputs. Copy that print statements. And you know what? This time around, I'm going to actually change the acceleration. And I'll send it my while loop. Let's see what it says. You fix the discriminant, but one critical part is still wrong. The denominator right now. Oh, yeah. Okay. Yeah, that's fair. A does appear in that equation. It actually probably even told me in the first prompt how to do it correctly. I'm going to go back and see if it... No, it did. Well, yeah, fair enough. It didn't tell me. But it doesn't have to tell me. It can't solve all my problems in one go. can only solve your problems one prompt at a time. But now what was I going to do? I was going to do divided by 2a. I think it just wants me to do divided by a. Great. Please, I'm getting desperate now. I'm feeling, this is the point where I said at one point in this process, I said after you get rid of your first bug, you can't just expect there to not be any more bugs. I'm sort of getting to the point now where I'm feeling like I've got my bugs sort of debugged and I'm ready for this to just work now. I forgot to make the marble fall faster. I could it'll complain. No, I'm not even gonna. I don't like it when it complains to me and it says you have uncompiled changes. Do you want to keep debugging? And we see. Yeah, we're getting through. Please. Distance 0. What? I mean, that's good. I sort of don't even believe it. What will happen if it keeps going? Well, it did keep going. I didn't exit properly. Why did it? Even if it kept going, I sort of thought that it would find that the new t is just the old t. So I wonder, I can get out of this. I can just check that my distance is very small and then exit on that condition. I just want to try to understand why it didn't work. So the distance was 0. And it found two t's, t1 and t0, or t1, t2, which were, t2 was negative 0.000. So what does that mean? It says if t1 is greater than 0, pick t1, otherwise pick t2. That's dubious logic. At best. What does that even mean? That's like T1 is always going to be bigger than T2. There's like some attempt to grab the positive root, but T2 is... Wait. No, like, that sort of makes sense. It's like T2 should be the bigger one, but if T1 and T2 are both bigger, then pick T1 because it's positive. But this whole thing is, it assumes that one of them is positive. Which is like, if I'm stepping forward in time, marble leaving, eventually it does leave, and then both roots are behind it. So what? I need to be prepared for this thing to have both solutions be negative. And if both... what do I do here? If one solution is positive, one solution is negative, pick the positive. If both solutions are positive or both solutions are negative, I suppose pick whichever one is smaller, absolutely. I guess. Okay. But this is initial logic. If T1 is greater than 0, so T1 should be smaller. Yeah, there needs to be, if T2 is less than 0. That's what it is. Okay. If T1 is greater than 0, T1. How do I do this? Is T already defined somewhere? It must be, okay. If T1 greater than 0, T is equal to T1. Else, if T2 is less than 0.0f, T is equal to T2. Else, I guess whichever one is smaller. One is positive, one is negative. What does that even mean? To have one root be positive, one root be negative. Let's say it was a plane. Trying to intersect a plane. Both values are negative. Both values are positive. Positive. It's just the positive one. If one value is negative, one value is positive. The only reason there'd ever be two negatives is because this search has overshot. Is there something about if both values are positive, I should choose the bigger one? No, because that might be like if I'm hitting the top of the sphere, I'll want the smaller of the two positive values. And if I'm going back, I want the absolute, sort of the absolute. So yeah, if T1 is positive, then that means they're both positive, and that means I want T1. If T2 is negative, that means they're both negative, and I want T2, and otherwise that would be T1 is negative and T2 is positive, so I want T2. Okay, build. I think this is it. Wish me luck. I think it's gonna work. I think this is the one. I did not speed up the marble. It is still a slow marble. One of these days, actually after it bounces, of course I'm gonna bounce the marble. Here it goes. It's falling. 10% down. 50% falling, 75% falling. Boom. Impact. Okay, distance, 37 millimeters. Distance, positive 0 millimeters. And I'm being silly. I should just fix this the proper way of figuring out if the distance is small enough. But it just did strike me as broken, and it was broken, that it needed to, and it still does. It still leaves, it finds the solution, and then it quits. Why must we do this dance? Let's just see what happens for a little while. It just goes back to, funny enough, exactly where it came from. It goes back to 37 millimeters somehow. Maybe it's because, and this would be odd, I hate to be learning this on video, but I call my distance and my speed const inside of while loop. That would surprise me. I feel like chat would have called me out on that at this point if that was not okay. And of course that's not it, because the distance and speed are changing. Distance, speed, acceleration, I find T1 and T2 Interesting. Okay. So, wait, T2 is negative 0.0. It would be interesting if that's not less than 0, which could be true. That might be it. Half width. I might need some more print statements in my logic about T1 being greater than 0 and T2 being less than 0. Because what happened? Am I not printing T anywhere? That would also be a useful thing to be printing. Maybe it's some completely different thing, like the discriminant. No. The acceleration? No. Distance, speed, acceleration. Half width. T1 is negative 1.57, T2 is 0.00, and then T is negative 0.00. And it keeps going, which should be fine, I figure. But the next time it'll plug. Wait, okay, so this, when T is 0, oh, I'm doing something a bit weird. Of course I am, it's broken. Maybe I'm misunderstanding the meaning of these T results, T1, T2. So if I have T2 is 0.0, I'm saying I found my result. That seems maybe not quite right. So distance is 0. That means I found my result. And somehow that's being converted into T is equal 0, but that's wrong. If distance is equal to 0, T shouldn't equal 0. I'm going to say that to chat, see what it thinks. If distance is 0.0, then T shouldn't be 0.0. I'll send it what happened. I'll send the log. You're extremely close now. Your math is correct, but two numerical issues are causing the oscillation you see. Your log shows the exact failure mode. So the solver finds the root, but then steps backward to T is equal to 0. Oh yeah, no, I'm being I don't want to say it, but I was saying that T is equal to 0 is good, but it's not. I'm not trying to solve T is equal to 0. I'm trying to find T that causes the function to be 0. when distance is 0, you already found the root. Yeah, I mean, fair. Maybe your logic allows negative steps, which is exactly what happens. Instead, you want the smallest positive step. Do I, though? I want the smallest positive step. I guess that's right, because T describes the approach, like A, B, and C could be negative or positive values, but T just means, it's the dependent variable, and I want destination to be 0. It still like sort of bugs me a little bit that I don't really know how to interpret. Your root selection logic is wrong. Maybe this will just tell me. Why do I need a positive step? I feel like it could be that I overshoot and I need a negative step. But if I overshoot, the A, B, and C will account for that, I suppose. So it wants me to do if T is greater than 1, if T2 is greater than 0, T2. Otherwise, if it's infinity, just break. I don't know about that. I'm going to try it. Why do you want to... I'm supposed to be incrementing this value? My result here, I'm supposed to be... That's crazy. I don't know if that's right. It says important. These are delta t values, not absolute times. I'm getting roasted out here. That's why the first iteration works so well. Because you start from 0 and you add it. But I just assign it. But that works on the first time through. Okay, I can buy that, I think. And I'd like to... It's telling me to break once I've found the distance is 0, but I'm sort of convinced that... I mean, I will do that. That is better. But there's no reason that this should break, and I'd like to know why it's breaking. Otherwise, it'll come back up later, I'm sure of it. And you know, this is the day. This is the day where I make the marble faster. It's proving to be a little bit harder than I thought. Oh, here it is. It was only 0.04. Like, if I turn it up to 1, that's going to be such a dramatic... I wonder what's going to happen. This makes me think I'm doing something not right. No, that's reasonable. Okay. Hits the floor. What do I see? What was I here? I wanted to see if my T update was working now. Okay. My new T is 0, so something's gone wrong. how did this happen? T1, T2 are both valid. I think they've changed, which is, all right, because my speed's changed, so that would make sense. My T1 and my T2 are real values, but nonetheless, my dt has remained unassigned. I say if T1 is positive, which it is not, okay. So then if T2 is positive, then, oh, you jerk. Okay, so my logic before chat screwed me over was way better. Okay, I'm gonna go back to what I had. Your current code. Thank you for referencing my quote-unquote incorrect solution that I can now use to paste back into my code. But it is good. It was a good note that T is a diff and not something absolute. Yeah, that sounds right. That seems right. But then what's the logic? Then what do I want? Do I really just want to... So what were my two results here? I think I always want... If they're both positive, then I want the smaller result. And then if a T1 will always be smaller, so if T1 is negative, I don't even need to use that min there. If T1 and T2 are both positive, T1. If T1 is negative, then T2. I think that's literally all it is. I think it's that simple. It's that simple. It's that simple. And this time we're doing the plus equals. I think the plus equals on the T is gonna bring this whole thing together. I think it's gonna really work. I think today's the day that the marble bounces. Here we go. All right. I forget that it hits the break point. It's a little bit anticlimactic. Okay, how are we looking here? We see some T values. It picks the right T value. T is updated. Let's see now. Distance is 0.00002, which is a little bit strange. I don't know why it does. Oh, right, because I changed the gravity. So it's moving faster now, so it's going to not get it in the first try. And what do we see now? I see that this is reassuring. I found that T2 was negative 0.000002, and that my running T has updated just a little bit, which is, I think, going to solve my oscillation issue. The distance is now 0, which is beautiful. What do I see here? I see that in my next step, my T2 value is 0.0000, absolutely. My T value has remained unmodified, which means that my code is stepping out. And I think the next thing for me to do is to just... Oh no, what a drag. I think it's not going to work. I'll see. I think it's going to pretend like it's going to work. It's going to say it's going to like bounce, but then I'm going to need to print some yeah, it doesn't really want to change speed. It just wants to power on through. I think I haven't really changed my velocity correctly. Marble hit ball. Marble collide ball. Right, this is... Oh yeah, it's getting good. And then this would be a good time to go into what happens at the collision. Okay, well, I'm going to take another quick break, and then I will take some notes on how the collision works, the new output velocity, and then I'll debug that. Okay, so it was marble collide time. This seems like a great time for a bit more explanation on the collision, and then some more debugging to get this part working. So there is a marble inside a ball, and it is going to hit the ball, and when it does, a few new concepts: a contact normal, so about this contact normal, this is the momentum is going to reflect off, sort of depending on the incoming angle. It's gonna bounce. So what is the contact normal? The contact normal is in line with the relative position. Whatever that vector is between the marble and the ball center is also the collision normal. So we had a name for that. I think it was A. I think it's just A over unit A is contact normal. I'll call it NC. Hat. Love hats. Length of 1. I see a bug here already that I should fix. I've normalized marble position, but it should be marble position minus ball position. That's what the collision normal really is. Oh, that would already cause so many problems. I'm not going to say that alone will fix it, but worth getting an initial print statement in here. Contact normal. Let's get that printed. Or I call it collision normal in my code. Okay, collision normal. Okay. And then I'm going to print this next one and then explain what it does. And do you know what? I'm so good for thinking of this now. I'm going to start building this code while I make notes on this next one. It's perpendicular velocity. So when we have a collision, there is the incoming velocity can be broken up into a component that is perpendicular to the plane and a component parallel to the plane. The velocity perpendicular is the direction of the normal times the magnitude in that direction. And that can be found with dot. So that will be the length of V in line with NC. Is that done? I thought there was more than that, but that might be it. I think it helps that NC is a unit vector. It could be more complicated, but it's not. Okay, I think that's right. It was simpler than I expected. And then the parallel component is subtract off the perpendicular component. And then, so now we have this vector, which is two components, the parallel component and perpendicular component. And the output vector is the parallel component and the perpendicular component, -1. So the output of the bounce is the parallel component, and I have a factor here. I can't think of a name. D, I guess. Plus, no, more like minus. Minus the, what would you call it? The perpendicular component. And that has like a bounce. 90%. It doesn't all come through. Okay, time to run some of this. Perpendicular velocity, parallel velocity, new perpendicular velocity. Let's see how it goes. Collision normal is... Oh, I messed up my printing again. I'm not printing the XYZ component. How does it let me do that? How could that be so wrong? To print a vec3 into where float's supposed to be, and it gets it so wrong. Maybe there's some compile time stuff I don't understand. Okay, so also while we're here, print the parallel velocity. And the new perpendicular velocity. Okay. Collision normal, perpendicular velocity, parallel velocity, new perpendicular velocity. It probably couldn't have hurt to... Well, I mean, at some point I just got to run it. But eventually I'll get to the new marble velocity. Let's see here. Collision normal. Um, 1J. Works for me. We're falling down, the collision is up. Perpendicular velocity. What do we see here? Negative 6.01504 J. How do I feel about this value? It's falling down. The contact normal is pointing up. The ball is falling down. I like that value. Parallel velocity, 0. I like that too. New perpendicular, moment of truth, 0. I do not like that value. Probably the marble bounce is 0. Yeah. I never initialized that value. Okay. Marble zeroed up. Marble. Where do I initialize the other stuff? The code's getting too long. It's not. That's not true. Don't tell anyone I said that. Okay, I know it's 1.9. There it is, okay. Bounce. Bounce, how bouncy? No, don't tell me. 95. .95. Oh, it's getting very close. It's getting very close to working. Collision is what it was. Perpendicular velocity. All right, I see a positive. New perpendicular is 5.714. .254. And I also have this if statement. If length of perpendicular velocity is less than 0.000001, I'm going to try to transition into, like, add a contact to the marble and start moving into a roll type of logic. But that's not for today. I just want to see it bounce. Why didn't I do this? I didn't print the... I mean, it seems you can't take any line for granted. You have to print them. Or at least I do. The marble velocity is equal to... well, it's just this term down here, I think. I'm looking at it. I have what's called parallel dryness times parallel velocity plus new perpendicular velocity. But the bounce has already been resolved in this new perpendicular velocity has already incorporated this B term. So I'll just do this one last print. I'm very excited. I think it's going to work. I don't know what else it could be. I don't know what else could go wrong. I mean, I always don't know what else could go wrong, so I don't know why I even say that. One last build, one last run. Actually, not one last run. Once it works, I'm going to watch it go, you know? Yeah, the outgoing marble velocity looks correct. Yeah, it bounced up. It's bouncing a second time, but a little bit lower. Why am I describing this? I'll just transition to footage. All right. So, bouncing. There we go. The gravity is aligned with the bottom of the phone in this build. I don't think it's going to be that way. It might be that way. But that means I can flip it upside down and get on the roof. I don't think it's going to be like this. But it is at least interesting to... So this isn't a marble, notably. It is a plane, and I have compute kernels started, meaning compute kernels, they don't draw to the output directly. They can create other sorts of resources. So I'll draw a marble onto this plane, and then I'll use that image of a marble on this plane, and it will look like a marble's there. But it's not really a marble. It's a plane with a texture, and the texture is an image of a marble. And I'll draw that image of a marble in a compute shader. And I'm going to do it that way because it's going to be a ray traced marble. It's going to be reflective and refractive, and it's going to use an accelerated version of the level. It's going to look very cool. Stay tuned.